We're here at Mobile World Congress Americas in San Francisco to talk with Durga Malati of Qualcomm a little bit about millimeter wave technologies. So obviously it's a big part of delivering a 5G experience, but so much of the attention around millimeter wave has been focused on fixed wireless access. Is millimeter wave just for fixed, or can it be mobilized and brought into that 5G environment?
One of the things that we have done is, as we've been building up our test bed and understanding the channel and the propagation, we've also been building up our prototypes to see what algorithms actually are key to making sure that this becomes a mobile system. We've done lots of tests, and some of these demonstrations have been shown earlier this year and at MWCA Americas as well, where now we believe that there is good reason to be a little optimistic towards how we can use millimeter wave as a mobile system. The ability to track and steer beams towards given users is something that is now an integral part of 5G and our specifications. We've been driving all of our studies into the specifications as well. And so today we have tests in which we've taken handsets into a mobile van that's moving around, or in a cart in an indoor environment and outdoor. The ability to steer beams in the direction of the users, the ability of the user to switch from one access point to the other in a very fast manner. These are key techniques that now have been built up, not just as a part of our algorithms and studies, but now they're a part of the standards process as well. So we feel pretty optimistic about the way we can actually get all the capacity that we can from millimeter wave.
And one of the big announcements that Qualcomm has made during the show is their millimeter wave prototyping platform. So can you tell us a little bit about that and how it's going to really help operators understand how to handle millimeter wave propagation and apply it to that mobile use case?
That's correct. So we've actually done two things. One is we have a fully spec compliant prototype baseband system, which is something that we are now going to be using for interoperable tests with all of our infrastructure partners. But the main point is that we actually want to mimic real-world environment so that by the time commercialization comes into play in 2019, we are ready with everything. So in taking steps in that direction, what we did is we actually took a handheld form factor device, and we have antenna elements and integrated RFICs as a part of that form factor device. That enables us to experiment with, well, you know, humans actually, we tend to use our phones in multiple ways, we catch it in multiple ways. And if you now start doing tests with these handheld form factor devices, then we can mimic hand blocking, head blocking, self-body blocking and other body blocking as well. So what happens is that if I'm holding a phone and if I turn around, then I might actually have to switch a beam very rapidly towards another access point, or maybe towards another beam in the same access point as well. But we want to actually prove it out using a handheld form factor. We've done these studies very well, but this millimeter wave prototype that we are talking of is something that we've been building for spec compliance interoperable testing. Eventually, this will set the stage towards field trials sometime next year after the specifications are completed.
Well, the development seems to be really speeding up, and it's great to get a better idea of how Qualcomm is helping really spur that on.
Yes, it is. In fact, we've made so many announcements with a lot of our infrastructure partners, dating all the way back to last year actually. We've made announcements with Ericsson, with Nokia recently, with ZTE. We're working with all of our partners, and both in the infrastructure and in the mobile operator community, because one of the next things that's going to come up is, right now we are doing a lot of these interoperable tests with our partners. But what you're going to see is that sometime next year we will have field trials coming up as well. So the idea is to, as we are preparing for 2019 commercialization, we don't have to wait all the way till there. We actually want to get started as soon as possible, not just in a proprietary manner, but really in a spec-compliant, interoperable manner with our partners, so that as these deployments come up in 2019, we've kind of already gone through a lot and therefore seeded the commercial deployments well.
So from just a broad ecosystem perspective, do you feel like everything is coming in line to really support a rapid commercialization of 5G?
I think we are taking all the right steps and things are coming along. We are pretty pleased and happy with how progress has been made on several fronts. I'm not going to be able to predict exactly how things are going to happen in the 3GPP standards process, but there is a genuine desire to make sure that we stick to the timelines that we talked of. So that means that functional freezing of all the non-standalone mode specifications towards the end of this year, formal specs done by Q1 of next year. That means all the layer 1 and the layer 2 aspects are actually solidified. That's like the building block anyway. And then standalone mode is going to come up sometime in the second half of next year. The official date is Q3 of next year is when the ASN1 freeze occurs. So that's like the formal specs are completed. So if that specification timeline holds, and we are driving that along with our partners in 3GPP, then it will also set the stage towards these interoperable tests. Because if that spec process starts slowing down, then we can actually interoperate very easily. So everything is coming. We are pretty happy with how things have come up so far. Lots of work ahead of us, but we look forward to it.
Well, Durga, I appreciate you taking the time to share Qualcomm's leadership role in the space with us.
All right, thank you.